Hello, in this video I will go over how to solve first-order differential equations when given initial values. I will go over the steps for solving a separable equation and solve for general solutions when given an initial constraint. So separable differential equations, you probably went through this if you took a differential equation. So this should, if you already did, this should be review. So what is a separable differential equation? It's basically if the equation can be written in the form of dy dx equals f of x times g of y, then you're dealing with separable differential equation. Then we can write it in a differential form as 1 over gy of dy equals f of x d of x. So basically what they did was they cross multiplied and get all the y's and x's by itself. That's all they did. Okay, so then we integrate both sides to give us a general or particular solution of the differential equation. Sometimes they might give you an initial value and sometimes they might not. So you may have a C and you may not have a C. So first step, you can only cross multiply and try to get all the X's and all the Y's on one side. Okay, once you've done that, step 2, integrate both sides. And then step 3, solve for C if you are given an initial condition. If not, just solve. Then solve for Y. That's it. So let's start with an example 1. So we have dy over dx equals 3 of x equal 3 dy over dx equals 3x. Find y. So this is definitely a separable differential equation. So first step I'm going to do is separate. Or you can think of it as cross multiply. Okay, so this 3x has a denominator 1. Go ahead and cross multiply. So 1 times dy is dy. And then 3x times dx is going to be 3x dx. Okay, now we don't have to go any further. We don't have to move anything more because we have all the x's and all the y's on one side. So step 2, I would integrate. Right? So go ahead and integrate both sides. Integrate the left as well as integrate the right. Okay. We know that the integration of dy is just y. And we know the integration of 3x is 3 half x squared. And then don't forget you have a plus c. Now, step 3, solve for c if given initial value, right? Unfortunately, we do not have an initial value. We don't have a coordinate, an x or a y coordinate. So our c is just c. And step 4, solve for y. We already did that because the left side was easy. The integration of 1 dy is just y. Okay, so what this means is y equals 3 half x squared plus c is your final solution. Okay, not too bad. Okay, let's move on to example 2. Example 2, we have dy over dx equals x over y, solve for y. So step 1, separate. Or cross multiply, right? So y times dy is y dy. And then x times dx is x dx. Okay. Step 2, wait, do we have to move things around anymore? No, because As you can see, we have all the y's and all the x's on one side, so we're good. Step 2, integrate. Okay, so the integration of y is not, it's going to be 1/2 y squared equals, and the integration of x is 1/2 x squared, and then plus c. Now, I forgot to tell you one more important thing about the c's. C on the left, you actually could have added plus c. Actually, both sides you could have did a plus c, but you only need one c. And usually you add the plus c, so you add the plus c on the x. You could have just done it on the y, but then you would have to move it to the, it's just more work. So you just have to remember, if you don't have an initial value, your plus c is always near the x on the x side. Okay, and then step 3, solve for c. Do we have an initial condition? No. So we can just move on to step 4, solve for y. Okay, so how would I solve for y? Well, first I would get rid of the fraction by multiplying everything by 2. So 2 times 1/2 y squared just cancels the 2. That gives you y squared. 2 times 1/2 x squared, the 2's cancels, you're left with x squared. And don't forget, you have to do it on everything as well as the c, so plus 2c. Okay. And then go and solve for y. So I'm going to get rid of this power 2 by taking the square root of both sides. And you get y equals plus or minus square root of x squared plus 2c. Now I'm going to keep the plus or minus sign because we don't have an initial condition. So we don't, it could actually satisfy both conditions. So yeah, that's why I'm going to add the plus or minus. Okay, let's move on to example 3. So example 3, we have dy over dx equals xy of y of 0 equals 1, and we need to solve for y. So this time they do give you an initial condition. Y of 0 equals 1 is actually a coordinate. It's like 0 is your input, and then 1 is your output. So 0 is your x, and 1 is your y, right? So you can write it as a coordinate as well. So step 1, separate. By cross multiplying, right? So yeah, go and cross multiply. 1 times dy is dy. Dx times xy is just xy dx. Then what we have to do is we have to make sure we get all the x's and all the y's on one side. So what can I do? Just have to get rid of this y. So to do so, I'm gonna like divide both sides by y or multiply both sides by 1 over y, right? Okay, so that's canceled. So on the left side, you're left with 1 over y dy equals to x dx. Okay, step 2 is integrate. Okay, so the integration of 1 over y dy is actually the same thing as the ln of absolute y, ln of absolute y. And then the integration of x dx is the same thing as 1/2 x squared. And then don't forget you have to add that with plus c. Okay, and then I would step 3 is solve for c because now we have an initial condition, right? Our initial condition is 0, comma 1. So 0 is your x, 1 is your y. So the ln of y, or 1, equals 1/2, and then replace x with 0 squared plus c. 1/2 times 0 squared is 0, and then plus c, so you don't really need to add that plus 0. And what is the ln of 1? Is 0. So 0 is your c. Okay. Then we'll solve for y. So we had ln of absolute value y equals 1/2 x squared plus c. Oh, r plus c is 0, so you could just replace c with 0. Now, how do we solve for y? Well, we have an ln, so there's a big clue. I'm going to have to take the e of both sides. So e ln of absolute value y equals e of 1/2 x squared is the same thing as x squared over 2. So on the left, e and ln are inverses. That's good because now that just gives you absolute value of y, which is really just positive y. And then on the right, it's just e raised to the x squared over 2. Okay, let's move on to example 4. So in example 4, we have y prime equals y plus xy. Find the general solution. So yeah, step 1, I'm going to, you know what first I'm going to do? I'm going to rewrite y prime as this. That is the same, if you done implicit differentiation, y prime is the same thing as dy dx. Y, and then this is stays true. Okay, then step 1 is I'm going to separate. Now, I have to cross multiply, but before I cross multiply on the right side of the equation, is there anything you can do? Yes, you can factor out a y. So that's what I'm going to do. So this is going to be 1 plus x, and then this is dy over dx. And this is all over 1. Then what I would do is, so yeah, cross multiply. So that's the same thing as separation. So go ahead and cross multiply. 1 times dy is dy. This whole thing times dx is just that whole thing times dx. Then what could I do next? I want to get all the variables on the same, get all the letters on one side. So maybe get rid of this y, or move it on the other side. So I'm going to divide both sides by y. Okay, so on the left, now you're left with 1 over y dy. And then on the right, the y's cancel, so you're left with 1 plus x dx. Okay, once I did that, the next step is integrate. Go ahead and integrate. So this is integration of 1 over y dy equals the integration of 1 plus x dx. Okay, so the integration of 1 over y is, oh, don't forget, so this would, the integration of 1 over y is ln of absolute value y. The integration of 1 plus x dx, well, you can just take the integration plus each term. The integration of 1 is x. The integration of x is 1/2 x squared. And then don't forget the plus c, because the c usually goes with the x's, right? Uh, Now, can we solve for c? Do we have an initial condition? No, we don't. So we're just going to set it up, just going to leave that plus c. And then step 3, solve for y. So how are we going to solve for y? Well, I have an ln, so that's a big clue. I would have to just take the e of both sides. So it's going to be e of ln of absolute value of y equals e raised to this whole thing, including the c. So this is going to be x plus 1/2 x squared plus c. And just clean it up. So on the left, e and ln cancels, and we know that the absolute value of y is positive, so you could just say positive y. And then on the right, there's nothing more you can do. It's just e to this power. So e to the x plus 1/2 x squared plus c. That's it. There's your answer. Let's move on to example 5. Example 5, we have dy over dx equals y over x. We have y of 1 equals 2. What is y? So we have an initial condition. Our initial condition is 1, 2. Or you could think of this 1 as your x, this 2 is your y. So step 1, separate. Go ahead and cross multiply. So x times dy is x dy equals dx times y is dx y. Let's see. What can we do? We need to get all the letters together. I mean, get all the y's on one side and get all the x's. So let's see. Let's get rid of this y. So I'm going to divide both sides by y. So now you get x dy over y equals to dx. Then what I would do is move this x to the other side by I guess how to get rid of this x, so I can multiply both sides by 1 over x. Okay, so this cancels. So on the left side, you're left with 1 over y dy, and then on the right, it's 1 over x dx, right? Okay, the next step is integrating. So integrate both sides. So it'd be integration of 1 over y dy equals to integration of 1 over x dx. So the integration of 1 over y is ln of absolute value y. The integration of 1 over x is ln of x. And then you have a plus c. So this time, step 3 is find the c. We are given an initial condition of 1, 2. So 1 is your x, 2 is your y. So it's ln of absolute value of 2 equals to ln of 1, absolute value of 1 plus the. So the ln of 1 is 0 plus c, and then the ln of 2, I'm just going to leave it as ln 2. And you know the absolute value of 2 is just 2, so you could just put it as ln parentheses 2. So that means your c is going to be just ln of 2. Oh wait, that's not our answer, that's just our c. So the next step is solve for y. So solve for y. Okay, so we have ln of absolute value y equals ln of absolute value of x, and then our c is ln of 2. Okay, so how are we going to solve for y is, because there's an ln, we're just going to have to take the e of both sides. So e, on the left, it's going to be e raised to the ln of absolute value y. On the right side, it's e raised to this whole thing, ln of absolute value of x plus ln of 2. Okay. Now what happens is the e and the ln cancel, so you're just left with y equals to e of ln of x, or ln of absolute value of x, plus ln of 2, and that's it. So this is your final answer. So let's move on to example 6. So we have y prime equals 4y equal, comma, y equals 4, and when x equals 0, find y. So first step is y prime can be expressed as dy over dx equals to 4y. And then we have an initial condition of x equals 0 and y equals 4, or we can write it at 0, 4. Okay, first step is separate or cross multiply. So this has a denominator 1. So 1 times dy is dy on the right, and then 4y times dx is 4y dx. And we have to get all the letters on one side. So this y should not be here. So I guess you can divide both sides by y. Okay, so now on the left, you're left with 1 over y dy, and then on the right, you're left with 4 dx. Okay, the next step is once we have all the letters all together, integrate. So it's the integration of 1 over y dy equals the integration of 4 dx. So what is the integration of 1 over y? It's just ln of absolute value y. And then what is the integration of 4 of dx? It's just 4x. Don't forget you have to add a plus c. And then solve for c by plugging your initial values. Your initial condition is 0, 4. So 0 is your x, 4 is your y. Go ahead and plug it in. So ln of absolute value 4 equals 4 times x plus c. 4 times 0 is 0 plus c, that's c. And then you have ln of absolute value 4 is just positive 4, so you can just say parentheses 4. Okay, so this is our c. Now the next step is solve for y. So go back to here. So it's going to be ln of absolute value y equals to 4x. And then our c is, you can replace c with ln of 4, right? Okay, now we're going to solve for y. So we have an ln, so I'm going to take the e of both sides. So e raised to the ln of absolute value y equals e raised to this whole thing. So it's e raised to the 4x plus ln of 4. Okay, so on the left, e and ln cancel, so you're just left with absolute value y or y. And then on the right, it's just e raised to the 4x plus ln of 4. Okay. Now, can we leave it like this? Can we simplify? Yeah, we could actually go a step further. See, this is e raised to the 4x plus ln of 4. Well, this is the same thing as saying as e to the 4x times e to the ln of 4, right? Remember your expanding rule. If you're adding, you're really multiplying. Okay, now over here, e and ln cancel, so you're just left with 4. So you're left with y equals, and you could put this 4 as a constant, so you could put that front, and then it's e to the 4x. Okay, move on to example 7. Example 7 says dy over dx equals 2y squared when y equals -1 and x equals 1. Then when x equals 2, what should y equal? Okay, so this one, they give us an initial condition, and then they also give you an extra x value, and we got to figure out what the y value is. So what I would do is step 1, separate. So it's going to be dy over dx equals to 2y squared. Go ahead and cross multiply. So 1 times dy is dy. And then 2y squared times dx is 2y squared dx. And then what you would do is get all the letters bytes together. So move this y squared to the left by dividing both sides by y squared. I get 1 over y squared dy equals to 2 dx, right? Step 2, integrate. So this is going to be the integration of 1 over y squared dy equals the integration of 2 dx. Okay. Now, be careful. 1 over y, the integration of 1 over y squared is not ln of y. It would if it was 1 over y, right? So what you're going to do is just rewrite. You could rewrite 1 over y squared as a negative power, so that would be expressed as y to the -2 dy. Okay. So what is the integration of y to the -2? It is y to the -2 plus 1. So that would be -1 over -1. So that would be -1 over y. And then on the right side, what's the integration of 2 dx? That is just 2x, and then don't forget the plus c. And then solve for c. So yes, step 3, solve for c, because we do have an initial condition. Our initial condition was x equals 1 and y equals -1. Okay, so replace your y with -1, replace your x with +1. So it's -1 over y, which is -1, equals 2 times x is 1 plus c. -1 divided by -1 is +1, and then 2 times 1 is 2 plus c. Solve for c, so you're going to subtract 2, you get c equals to 1 minus 2 is -1. Okay, step 3 is solve for y. So where do we go back? Let's go back to here. So go back to here. So that is going to be -1 over y equals 2x, and our c is -1. And then step 4 is solve for y. So how would I do this? I guess you can cross multiply. Uh, No, actually, what we could do is they want you to solve for y when they give you another condition when x is 2. So we got to solve for y when x is 2. So I'm going to plug in that 2 into this function. That's y times 2. 2 times 2 is 4 minus 1, that's 3. Then you can solve for y by cross multiplying. So 3 times y is 3y. 1 times negative 1 is negative 1. And then solve for y by dividing both sides by 3. And you get y equals to negative 1/3. Okay, that's your final answer. Okay, let's do a last example. Example 8. Okay, example 8 says we have dy over dx equals xy minus 2x over x squared plus 4. And then they give us initial condition of y1 equals 5, solve for y. So this is in your initial condition, 1, 5. Okay, so first I'm going to cross multiply. So this is going to be x squared plus 4 times dy. And then on the right, you're going to cross multiply. So it's going to be xy minus 2x times by dx. Okay, what would I do next? Yeah, what would I do? Maybe on the right, they notice how they both have an x. Maybe we can factor out an x. So this would be x y minus 2 times dx. And then over here, this is like x squared plus 4 dy. And then what I would do next is uh, I guess I could get rid of this x squared. Yeah, let's get rid of this whole thing, x squared plus 4, by dividing both sides by x squared plus 4. Okay, so now you have dy equals to x y minus 2 of x squared plus 4 dx. Now I want to get all the y's on one side and all the x's, so let's get rid of this y minus 2. And to do so, I'm going to have to multiply both sides by 1 over y minus 2, right? Okay, so now you have, on the left, you're left with 1 over y minus 2 dy. And then on the right, the y minus 2 cancels. You're left with x over x squared plus 4 dx. And then I would integrate. So yeah, so go ahead and integrate both sides. So I think we're going to have to do, on both integration, we're going to have to do use substitution method. So on the right side, our u would be x squared plus 4. And then my du would be the integration of the derivative of x squared is 2x, and then the integration of 4 is 0, and then don't forget to add the dx. So as you can see, we have to get rid of this too. So to do so, I'm going to multiply both sides by 1/2. So this is going to be 1/2 du equals to x dx. So this can be expressed as u, and then you can replace x dx with 1/2 du. And then this 1/2 is a constant, so you could just bring it out or put it in front of the integration. So now you have 1 over u du. And 1 over integration 1 over u is, yes, ln of u. So this is going to be 1/2, and then ln of absolute value of u, and your u is x squared plus 4. And then over here, the same thing idea, you have to do u substitution. Your u is y minus 2. Your du is I don't know, the derivative of 1 is 1. I mean, the derivative of y is 1, the derivative of negative 2 is 0, and then you have don't forget you have a dy. So it's going to be the integration of 1 over u, and then you can replace 1 dy with du. And we know the integration of 1 over u is the ln of u, and our u was y minus 2. Okay, so on the left, you have this ln of y minus 2 equals 1/2 ln of absolute value of x squared plus 4. And then don't forget you have a plus c. So our initial condition is 1, 5, right? So go ahead and solve for your c by plugging in your x and y. That's the ln of y, which is 5 minus 2 equals to 1/2 ln of x is 1 squared plus 4 plus c. So this is going to be the ln of 5 minus 2 is 3. And then this is going to be 1/2 ln. 1 squared is 1 plus 4, that's 5 plus c. And honestly, absolute value 3 is 3, absolute value 5 is 5, so you don't really have to put that absolute value. It's going to be 1/2 ln 5. And then go ahead and solve for c. So you're going to subtract, well, actually, remember, if you have a number in front of the ln or of a log, that is like a power, so you can rewrite 1/2 ln of 5 as the same thing as ln of 5 to the 1/2. And then anything raised to the 1/2 is the same thing as square root, so this could be ln of square root of 5 plus c. And then solve for y, so you're going to subtract ln of 5, subtract ln of square root of 5. You get c equals ln of 3 minus ln of square root of 5. Okay, and then now go back to, where should we go? I guess go back to, now we got to solve for y, so go back to right here. Go back to here, and then plug in your c and plug in your x and y. So it's going to be, or not, wait, we already solved for c, right? Yeah, so go back to here and then just plug in your c. So it's going to be ln of absolute value y minus 2 equals to 1/2 ln of x squared plus 4. And then our plus c is ln of 3. Oh, also right here, remember, you can also remember if you have a minus and you're condensing, minus means divide. So you can say this is the same thing as 1 ln of 3 over radical 5. Much better, right? So remember, if you have a minus and you're condensing, it means division. So I guess your c is going to be ln of 3 radical 5. and then go ahead and solve for y. So you're going to take the e of both sides. So this is going to be e ln of absolute value of y minus 2 equals e raised to the 1/2 ln of x squared plus 4 plus ln of 3 over radical 5. And then over here, e and ln cancel, so you're just left with y minus 2 equals to e. And then remember, if you have a power number in front of the ln or log, it's like a power. So this is like the same thing as e to the x squared plus 4 to the 1/2, or really this is the same thing as square root. So it's going to be ln square root of x squared plus 4 plus ln of 3 over radical 5. And because you can rewrite this part e raised to the ln of square root of x plus 4 plus ln of 3 over radical 5. That plus is like a multiplication. So you can rewrite this as two terms, as e to the ln of square root of x squared plus 4, and then times e to the ln of 3 over radical 5. Now on the left, you have y minus 2. And then what you could do next is over here, e and ln cancel, so you're left with square root of x squared plus 4. And over here, the ln cancels. And then this is times 3 radical 5. And on the left side, you're left with y minus 2. And then solve for y, so you're going to add 2, add 2. So you get y equals, I guess I could put this in front, so it's 3 over square root of 5 times square root of x squared plus 4 plus 2. There you go. That is your final answer. I will stop here.